This video is on solving linear inequalities. The differences between a linear equation and a linear inequality is first, that the linear equation has an equal sign, and then your linear inequality will have an inequality symbol. Then when you go to solve, you would actually solve this the same way. In both cases, you will subtract 5 from both sides. When you're solving your linear equation, you will get one solution, which is x equal to 2. 2 is the only value that will make that a true statement. But when you solve your linear inequalities, you will get infinitely many solutions. You will get a solution set. And here you will solve and get x is greater than 2. So all values that are greater than 2 would be a solution. In other words, they will make this inequality a true statement. So anything greater than 2, you're talking about 2.5, you're talking about 4, 100, 1 million. Anything greater than 2, when you plug it into this inequality, will make that a true statement. So your inequality symbols, less than with the bar under is less than or equal to, greater than, then greater than with the bar under it, greater than or equal to. We're going to graph and use interval notation. Whenever using the less than or greater than symbols, we will use parentheses, which means we will exclude the value that we see. If we have less than or equal to, greater than or equal to, we use brackets, which means we would include the value that we see. And I'll talk about that in a little bit. And then if we have the infinity signs, whether it's negative or positive infinity, you will always use parentheses on infinity signs because you cannot include infinity. You can always go to the next number. So what do I mean by include and exclude the value? If my solution set was x is greater than 2, that's all values that are greater than 2. 2 is not a part of the solution set. So that means 2 would be excluded. So if I saw the parentheses, then I will automatically know that greater than would be the symbol that I use here. 2 is not a part of the solution set. But if I have greater than or equal to, I want all the values that are greater than or equal to 2. That means 2 is a part of the solution set, which is included as a part of the solution set. So that means brackets would be used to also reflect the or equal to portion of my solution set. Here's a generic chart to help us when it comes to graphing and interval notation. A and B are going to represent real numbers in this chart. So if x is greater than a, don't forget your generic number line. 0 is in the middle, everything to the right of 0 is positive, everything to the left of 0 is negative. If I look at -2, everything to the right of -2 will be greater than it, everything to the left of -2 will be less than it. If I look at +1, everything to the right of +1 will be less than it, will be greater than it, excuse me. Everything to the left of 1 will be less than it. So when it comes to these shadings, it doesn't matter what this number a is. Now I'm looking at all the values that are greater than a. I want to shade to the right of a. Because I'm using the greater than symbol, I'll use parentheses, like I mentioned in the last set of notes. And then if it's greater than or equal to, I'm still going to shade to the right, but because it's or equal to, I will use the bracket. As far as my interval notation, that same thing should reflect what's going on in the graph. So notice this is going from a to infinity. You got this arrow here. The right arrow is to infinity. So that's why I have a comma infinity using parentheses on both. Infinities will always use parentheses sign. And remember, we use the greater than symbol, which warrants a parenthesis. Here, I'm going from a to infinity. And I'm going to use the bracket because I had the or equal to, but infinity will always have parentheses. For the next set, we're looking at the values that are less than a. Going to shade to the left this time, use parentheses because I'm just using the less than symbol. If it's less than or equal to, we're shading to the left, we use bracket. Now notice we graph from left to right. Notice we're coming from negative infinity to a. So that's the position here. We do not write a comma negative infinity. We go negative infinity comma a. Parentheses on my infinity sign, parentheses on my a, and then here parentheses on my negative infinity sign, and then bracket on the a. Here we have x, which is our variable, is greater than a but less than b. That represents all the values in between a and b. Both of them using the less than symbol, so I should be using parentheses over the a and b. And then in my interval notation, a comma b, parentheses for both. Here, notice we have the or equal to attached to the a, but not to the b. So we're still using the same shading as far as a between a and b, but bracket will be on the a, parentheses on the b. On the next one, shading in between a and b, but b gets the bracket, a gets parentheses. And then this last one, they both have the or equal to sign, so we use bracket on both. Still shading in between. So quick examples, just to put numbers on it. If I have x is greater than or equal to 5, I want the values that are greater than 5, so I'm shading to the right using bracket over the 5. And then that's 5 comma infinity, bracket over 5, parentheses over infinity. Here we have x is less than 10, so we're shading to the left using parentheses, negative infinity to 10 with our parentheses on both. And then for this last one, looking at the values that are greater than -8 but less than or equal to 12, parentheses over 8, bracket over the 12, shade in between. And that same symbolism should reflect in your interval notation. So we will solve, as I mentioned before, we will solve inequalities the same way that we solve equations, except that there's one thing that we have to consider. If you have to multiply or divide both sides by a negative number, then you must flip or change the inequality symbol. So if I have negative 3x is greater than 21 and I want to solve, you would divide both sides by a negative 3. And here, notice my symbol is going to change from greater than to less than once I finish dividing out and simplifying, which would be x is less than -7. And if you go to our other two pieces, the graph, you're going to shade to the left, parentheses over the 7, and then negative infinity to -7, parentheses over both for interval notation. So if I have -5x minus 3 is less than or equal to 12, just like you would solving a linear equation, add 3 to both sides. That'll be -5x is less than or equal to 15. Divide by -5. Once again, don't forget, if you're going to divide or multiply by a negative value, you change your inequality. So it goes from less than to greater than. The or equal to is still there. So we have x is greater than or equal to -3. Shade to the right, use a bracket, and that's -3 to infinity, bracket and parentheses. All right, a few more examples. Here we have 12 minus 2 times the quantity of y plus 3 is less than -3 times the quantity of 2y minus 1 plus 2y. Distribute the -2 and the -3. So that's 12 minus 2y minus 6 is less than -6y plus 3 plus 2y. Combine your like terms in each. 12 minus 6 is 6. On the right side, -6y plus 2y is -4y. Add 2y to both sides. Remember, at this point, you can do either whichever term you like. You can move whichever term that you like, whether it be 6, 2y, 4y, or 3. Just make sure you do it correctly. I decided to go ahead and add my 2y to both sides. They cancel on the left, leaving me with just 6. On the right, I'm left with -2y plus 3. Subtract 3 from both sides. Now I have 3 is less than -2y. Now divide by -2. And what I have is -3 over 2 greater than y. Don't forget, whenever you divide by a negative, you have to change that inequality. Also, if I wanted to write my variable on the left side versus being on the right side, I have to flip the whole thing. So one way of recognizing which way to do it and how to stay consistent, if the mouth is open towards 3/2, when the 3/2 is from the left, when I take my 3/2 to the right, the mouth should still be open towards it. So that means y is less than -3 over 2. Then from there, looking at our shading, we're going to shade to the left using parentheses over 3 over 2, and negative infinity to -3 over 2 using parentheses for both. Last one, if we have a 3-part inequality, remember the last few examples in our chart, we had the x in the middle and we had the 2 numbers on the outside. So that's the way we will handle this 3-part inequality. That's how we'll be looking to solve. Notice we have 3 different parts. That's why it's called a 3-part inequality. Whatever I do to one part, I have to do to all 3 in order to solve correctly. My goal is to keep x in the middle and solve for x. So I will I will subtract 1 from all 3 pieces. So that will cancel out in the middle. On the left, that will give me -4. On the far right, it will give me a +6. Now I'll divide all 3 pieces by 2, so I can get x in the middle by itself. -4 over 2 is -2. 6 over 2 on the right is 3. And now I have my most simplified solution. I want the values that are greater than -2 but less than 3. We're going to have the or equal to over the -2, so that's bracket, and then parentheses over the 3, shade in the middle, and then my interval notation is -2 comma 3 bracket over the -2 parentheses over 3. Let me know if you have any questions.